Hi everyone, so welcome back to a new video. Today's Leetcode daily challenge is binary tree in order traversal. This is an easy level question. So in this question we have been given a root of binary tree, and what we need to do, we need to return the in order traversal of its node values. What it means that we need to return the values of the binary tree in order. What does in order means? If this is a binary tree that we have here, so the value should come in order. What does if we consider in order, it means it will go from left to root to right. Okay, left to root to right. So this is the correct order for in order. Now, so basically what we have to return in the result here, it will be 2 comma 1 comma 3. Now we have the basic idea of what is an in order traversal, right? Now in the constants we have been given that the number of nodes in the tree will be ranging from 0 to 100, right? And they have also told that the value of the node will be lying from -100 to +100. Okay, and we know that the tree questions mostly we try to solve from recursion, but here in this they have given us a follow-up question that recursion since recursion is trivial. Okay, so they have asked us to try to do it iteratively. Okay, so now in this video we will be seeing the recursive as well as the iterative approach of solving this problem or the in order traversal. We will be seeing the recursive as well as the iterative approach. Now let's see the recursive approach. So let's say we have this binary tree 1 2 3 and we have 4 here. Okay, so what we have to do, we will come here. Okay, then we have 5 here, let's say. Okay, so we have to come here, then we have to move again to the left and again to the left. First we will be moving to the left and reach to the node where after that there are no values available. Okay, and or we can say that after which there is null. Okay, so here we see that there is nothing here. So what we need to do, our first value, the result that if we have a result as an array, so the first value contained in that result will be 5. So what I said was, in order, what we start from left, then we go to the root, and then we go to right. So now we have 5 here, and it does not have any values, neither on left nor on right. So it will get appended to the result and we will backtrack, and now we will see print this node 1, right? We will be adding this to our result and then we will move forward again. So we will add this one, and now what we have to do, we need to go to the right. So we will come to the right, we have some value here, and before printing this value we will check if in the left something is possible, something is there or not, and in right something is there or not. So in the left nothing is there, so what we will do, we will come back, we will add the value 4, and then again we will go to right, nothing is there, so again we will backtrack, and we will backtrack again, and we will backtrack again, because we have already visited this subtree, and we will backtrack to 2 now. So now this 2 will get added to the result. Now we have this 2, and now we will move to the right. So we have 3 here. Before printing this we will move to the left. Okay, so now we have moved to the left and we are seeing that nothing is there. So again we will backtrack and we will add 3 to the result, and again we will go to the right and check, nothing is there. So we will come back, and this is our required result. Okay, so according to recursive approach, what we have to do, we will call the help, if we have a helper function, okay, and it has root and result as two argument values. So what we need to do, we have to go to the value as left as possible. So we will move to the left of the root first. So we are moving to the left, and till when we need to move to the left, till we have values there, okay, till we have values there, till then only we will move. So we will give a condition here that if root is not equals to null, okay, if root is not equals to null, then only we will keep on moving forward, okay, or keep on moving left. Now once we reach the null value, what we need to do, it means that we have reached the leftmost value. So what we have to do, we need to append in our result. So we will append that in our result root dot val. Now what we will do, after coming here, we have added all the values left, root, and now what we need to do, we need to go to the right also. So after this, what we will do, we will move to the right, root dot. So this is the basic idea of what we will be doing in the recursive solution. First we will move to the left, then we will go to the root, and then we will go to right. So these are the three basic steps we will be following in recursive solution. Now let's see the iterative approach, okay. So in the iterative approach, like in recursion, what we were doing, we could backtrack in the tree, right? If we had reached null value here, okay, then we could backtrack to the root values, right? So in iterative approach, we cannot do that, we cannot backtrack, right? We can only move in one direction, either we can move forward or we can move backward. So we need to store the values whatever we are visiting, right? Visiting values need to be stored. So what we will do now, we will come here, okay. We will be having a data structure which will be storing the visited values. So we will take a stack and we will store these values whichever we have already visited, and what we will do, we will be having a value which will be storing the result, okay. So we have a result. Now what we have to do, we will be starting from here, we will be going here, and after that we have to come back and we need to go to the right. So if we have this value, so it has the position of its left node and its right node, okay. So basically we need each root node because it has the value of the left as well as the right node. So for every root node, we will check if left is available or not and if right is there or not. So in order to solve this question, we will keep the while loop, we will use while loop and it will be true, okay. So whenever we have run out of the nodes in the tree, or we don't have any more nodes in the tree, so we will just break out of the loop and we don't have to keep the count of the, or we don't need to iterate in the loop, okay. So we have declared this while as true. Now we have this root value, right, and we need to move left and we need to get the value of right also. So what we have to do here, if we have this stack, okay, so this stack is empty now, right, and we have, let's assign root to the to a variable, let's say it is current, okay. So now what we have to do, we have to check here, okay, if current is null or not. When we are on 1, we are here, current is not equals to null, right? So we are checking here if current is not equals to null. Now it is not null. So what we can do? We can simply append this value in the stack, right? We have visited this cell or we have visited this node. So we need to keep track of it, right? So what we will do? We will append this value in our stack. So first step here is we will be appending the value stack dot append this current. So we appended this value. Now what we need to do? We need to keep a track also, right? We need to see that if we have the left value or not. So we will check that. So we have added this value and we move to the left, current dot left. So value is still there. So we will just do current is equals to current dot left. Now we have moved to the left here, right? And if it is null or not, it will be seen after we come back here again. So we will check that it is null or not. It is not null. So again we append this value in the stack. Now we have 2 and 1 in the stack. Now what we need to do? We again come here. Okay, we will again move to the left. And when we check the condition now, this value is null, right? So once we touch the null value, right, in the tree we have reached a position where it does not contain any more values, right, in the left. Here we cannot move any forward. Now what we need to do? We need to add this, since it does not have any value here. That means this is the first value which needs to be appended to our result, right? So in such cases where we find that the current in the left becomes null, that means there are no more values in the left anymore. So what we will do? We will add this value in our result. So after this what we will do? We will check that else if stack is existing. If stack is, or we can say stack length is greater than 0. Length is greater than 0. Okay. Now we have stack length is greater than 0, right? So we find that stack length is greater than 0. We have 1 and 2 there and we need to get this value out. So what we will do? We will pop it out, right? So we will use current only, because if we have 2 here, right? So I already checked in the left, nothing is there, but there is possibility that some value will be in the right also, right? So what I will do? I will just store this current value, this popped out value, that is 2, in current. Okay, so I will pop this value and store in current. Now what I will do? I already checked the left value in the previous condition. Now I have to check in the right also that if value exists or not. So after appending this 2 in the result, okay, result dot append current dot val. Here we have the final result, right? It will be returned as the answer. So we will be appending the value in this. Now what we will do? We will move to the right. So we will move to the right. Current is equals to current dot right. Now we see that there is no more value, right? So we move to the right here, and then in the like we move to the right, that's it. That is what we were supposed to do here. Now again what we have to do? We will come and see that current has become null here, right? So again we will come and check in the for this second condition, right? This second condition we will check again that if stack is existing or not, right? Stack length is greater than 0. Yes, the stack length is greater than 0 because still 1 is there. So what we will do? We will pop this one out. Now we have this one popped out and we will append it to our result. So till now our result has 2 in it, and now we popped out one also, right? We popped out one and we will be appending it to our result. Now what we will do, we will move to the right of this current, right, or the right of this one. We have some value here, right? So what in this current 3 steps, what we are doing, we are just moving to the right. Okay, we are not doing anything after this. So again we will come to the top of the loop. Okay, on the top of the iteration. So what we will check here, current is not equals to null. Yes, our current has some values, right? We have 3 here. So what it will do, it will append it to the stack. So now our stack got empty, right? We popped 2 and 1 out of it. Now what we will do, we will add a value 3 to it. Now 3 has been added, and this 3, what we will be doing, 3 got added here, and now what we will do, we will move to the left of it. Okay, so we will move to the left, and these are the 2 steps that we need to perform if the current is not equals to null. Now again we will move out, we will go to the top of the loop, right? We will not go into the else block, right? Because we will only go into the else if block when our if condition is false. So again we see, we come here, we had moved to the left of the current, right? And we find that now after 3 it did not have any value either in the left or in the right, right? So we will go to this else if part, and we will see that stack length is greater than 0 or not. So this will become true, right? We have 3 here. So what we will do, we will pop it out and we will add it to our result. So now our result will have 2, 1 and 3. Now we have appended it to our value. We already checked that left means 3 had some value in left or not, but we need to check in the right also. So what we will do, we will move to the right, and again now what we will do, we will move here and we will check that current is not equals to null. But here we are finding that current is equals to null, right? And now what is happening here, we are seeing that stack is also equals means less, means it is equals to 0. Our stack also became empty in the previous step. Now in such condition, when current is equals to null, current also becomes null and stack is also empty. So it means that we have traversed through the entire tree, and now what we need to do, we need to break out of the loop. So what we will simply do, we have checked 2 condition here, if current is not equals to null and if stack length is greater than 0. So whenever both will become false, what we will simply do, we will break out of the loop. We will just do break. That's it. So this is the basic gist of what we will be doing in this question. So let's move on to the code. In the code I will be showing the iterative approach, and I will upload the recursion as well as the iterative approach on my GitHub repository, to which the link I will be mentioning in my YouTube description. You can access the code from there. So now let's move on to the code. So let's see the code now. So first what we will do, we will declare a data structure stack and a result array to store the final result. Now we have declared the stack and the result. What we will do now, we will assign the root to a variable, let's say current. After this we will start our loop. It will be true, and then first step what we had to do, we need to check if current is null or not. So if it is not equals to null, then what we were doing, we were appending the value to stack. So we will append the value to stack current. Now after this what we need to do, we need to keep moving left. So we will do current is equals to current dot left. After this, what we were checking? We were checking if stack exists or not. So we will check simply that if, else if stack exists or not. If it exists, then what we were doing? We were popping the topmost value, right, and storing it in current. So we will pop the topmost value, and now what we will do? We will append the value in result. We will append the value. Okay, here we were appending the current position, or we can say the, it stores the address of the current node, and here what we will do, we will just store the data stored in that position or the address. So we will do current dot val. Now we have appended the value. We will move to the right also in order to see that that current has some value in right or not. So we will move to the right, and if we find such condition when we have stack is also as empty and the current also does not have any more values, or it is equals to null now, then we will break out of the loop. So we will do else break. Now at the end of the loop we will just return result. Let's try to run the code now. So the sample test cases have passed. Let's try to submit it. So this code has been accepted. That's it for today, guys. Thank you for watching. If you found this video helpful, please let me know in the comments. And in order to continue with me on this Leetcode daily challenge journey, you can subscribe to the channel and hit the bell notification so you will be notified every time I post a new video. Thank you for watching.